Our first way to be lazy is to avoid doing any work until you know you need to do it. A link is really helpful here. Let's say I have a list of strings and I want to convert them to uppercase. We can do that quite easily with a link select statement like this. Now, if I run this code, how many times will the toUpper method be called? Have a think for a minute. If you said 0 times, then you're right. The select extension method doesn't actually cause the list of strings to get enumerated. Now it's hard to demonstrate this, but we could make this more obvious by changing the lambda we pass into select to be a method with two statements. The first one just calling console.writeLine for debug purposes, and then we'll return the string converted to uppercase. And now when we run this, we see that nothing gets printed in the results window. So why is this? Well, it's because select simply returns a lazily evaluated IEnumerable sequence. It's not until we actually iterate through that sequence, say with a for each statement, that it needs to read anything out of its source enumerable sequence, which is this list of strings. In other words, until someone actually needs to take something out of your pipeline, nothing in the pipeline needs to get executed. So let's call this sequence uppercase, and we'll use a for each loop to loop through that uppercase sequence and print out the results. And now when we run, we can see 2 of every string. First in lowercase, and that's coming from this console.writeLine here, and then in uppercase, and that's this console.writeLine here. Also, notice the order of the output statements here. We don't see all the strings in lowercase and then all the strings in uppercase. Instead, you can see the order that things were happening in the link pipeline. To read the first element from the pipeline, we needed to read the first string from the original sequence, which is Ben, and then it gets converted to uppercase. And only then, once we've pulled Ben through our pipeline, do we move on to get the next string. Perhaps it'll be clearer what's going on if we add another stage to our pipeline and put a where clause in, and this will filter out all the strings with a length of 3 or less. Now when we run, we see that the first lambda expression gets run on every string in the original sequence, even the short ones. And that's because this select statement with console.writeLine in it comes before the where stage in our pipeline. And so those short strings haven't been filtered out yet. Now let's make one last change. I'm going to add a call to the link toList extension method. But before I run, what change, if any, do you think this will make to the output? Let's run it and see. Okay, can you spot the difference? Well, now you can see that we have all the strings in the original sequence printed together, and then all the uppercase filtered versions. Now, why did the order change? Well, the reason is that toList and methods like it, such as toArray or toDictionary, will cause the entire pipeline to be evaluated there and then, and the results stored in memory. And there can be some good reasons to do this, and we'll be discussing some of them later. But it's really important to be aware that by calling a method like toList, or even link extension methods like max or all, you will there and then cause the entire sequence to be evaluated. Now, for this trivial example, it hardly matters, but sometimes there can be a real cost to evaluating your whole sequence unnecessarily. So let's look at an example now where it would make a big performance difference if we called toList.